A 54,000-pound jet hits a wire at 150 miles per hour and stops dead in less than 350 feet. Another jet is already being launched from the opposite end of the deck at the exact same moment. There are 5,500 sailors on board. The flight deck is 4.5 acres, and this happens 1,000 times a week, every week in the middle of the open ocean. No airport, no air traffic tower, no backup runway, nothing but water in every direction. And the US Navy hasn't just survived doing this, they perfected it to a level that would make your head spin. So how exactly do they pull this off? That question is what this video is all about. Because when you start peeling back the layers of how a US aircraft carrier actually runs its flight operations, the system, the people, the timing, the technology, you realize this isn't just impressive. It's one of the most remarkable feats of military engineering and human discipline that exists on this planet. And today, we're going to walk you through every piece of it. If you've ever served or have family who have served or simply believe America's military strength is something worth understanding, type proud in the comments right now. Let's get into it. The scale of what we're talking about. Let's start with the numbers, because the numbers alone are stunning. A Nimitz-class carrier, the kind the US Navy has operated for decades, can sustain 120 sorties per day under normal operations. That's 120 full jet launches and recoveries every single day. Stretch that across 7 days, and you're already at 840 flights per week. And that's just the baseline. Under surge conditions, when the mission demands it, that number climbs to 240 sorties per day. 240 in a single day on a ship in the middle of the ocean. The newer Ford-class carriers pushes that baseline even higher, up to 160 sorties per day in normal operations, and 270 during a surge. That's almost 1,900 flights per week when pushed to its limit. Now, when you hear 1,000 flights per week, that's not an exaggeration. That's not cherry-picked data. That's the actual operational tempo of what US carriers sustain during a real deployment. And the question that everyone should be asking is, how does a ship with a 4.5 acre deck manage all of that without things going catastrophically wrong? The answer starts with one word: system. Everything, and we mean everything, on a carrier flight deck is a system. There are no improvised decisions. There is no winging it. Every single person on that deck, every piece of equipment, every sequence of actions follows a precise, rehearsed, and deeply disciplined process. And that process begins long before any jet even starts its engine. The color code that runs the deck. Here's something most people don't know. On the flight deck of a US carrier, you cannot hear a spoken word, not with jet engines screaming at full throttle 20 feet away. So how do 200 to 300 people coordinate safely? In real time without talking to each other? Color. Every single person on the flight deck wears a colored jersey, and each color tells every other person on the deck exactly who that person is, what their job is, and where they belong. It's a visual language developed over decades of trial and error, and it is one of the most effective communication systems in military history. Yellow jerseys, these are the aircraft handlers and directors. They are the air traffic cops of the flight deck. They physically guide every jet from its parking spot to the catapult using hand signals and wand lights at night. If a yellow shirt is waving at you, your jet moves. If a yellow shirt holds up a fist, you stop. The air boss, the man who controls every aircraft with 5 nautical miles of the ship, also wears yellow. He sits up high in what the Navy calls pre-fly, which is basically the control tower of the ship. Green jerseys, these are the ones doing some of the most physical, dangerous work on the ship. They operate and maintain the catapult and arresting gear. They run the arresting wires, and the job of being what's called a hook runner is considered one of the most hazardous assignments in the entire Navy. When a jet traps the wire and lands, a hook runner sprints out to the aircraft and physically frees the wire from the tailhook so that the wire can be reset and be ready to catch the next jet landing, which is coming in less than a minute. Red jerseys, ordnance team. They handle every weapon that goes on every aircraft. Live bombs, missiles, ammunition. They all include crash and salvage crews, the men who respond within seconds if something goes wrong on the deck. Brown jerseys, plane captains. These are the sailors directly responsible for the care of specific aircraft, plan before it launches, check it after it lands, and are answerable for the condition of their jet. Purple Jersey, the fuel crews, nicknamed Grapes. They fuel every aircraft on that deck. They work around jet fuel in an environment full of heat, exhaust, and spinning intakes. One mistake costs lives. White Jerseys. These include landing signal officers, known as LSOs. These men are some of the most critical important people on the ship. They stand at the aft end of the flight deck as aircraft come into land, monitoring the approach of every single jet. They are talking directly to the pilot, guiding the approach, and they have the authority to wave off any landing they judge to be unsafe. No questions asked. This color system means that even in the noise of chaos of full flight operations, everyone knows exactly who is who belongs where, and who has authority over what. It removes confusion before confusion can cost lives. But here's the part most people never think about. All those jets landing at full throttle on a moving ship in the open ocean, the pilot is fully prepared for the wire to not catch. Every landing on a carrier is treated as possible failure from the start. And what happens when the wire doesn't catch and a 60,000-pound jet is still screaming down the deck at 150 miles per hour and nowhere to go? Is one of the most intense 30 seconds in all of aviation. We'll get to that. But first, let's talk about what happens before any of this in the 72 hours before a single jet leaves the deck. Cycle, how launches and recoveries are timed. The aircraft carrier doesn't just launch jets randomly throughout the day. There is a system called cyclic operations, and it's the backbone of everything. A cycle is a scheduled window, usually about 1 hour and 30 minutes long, during which the carrier launches a group of jets and then recovers them. Each group is called an event, and a typical event is made up of 12 to 20 aircraft. These events are numbered and sequenced throughout the entire flying day. Here's what the timeline of a single launch event looks like. 45 minutes before launch time, pilots walk around their aircraft and do inspections. 30 minutes out, engines are started. 15 minutes out, aircraft begins taxiing into positioning at the catapults. The ship turns directly into the wind to increase the airspeed over the deck, reducing the ground speed the aircraft needs to reach before safely getting airborne. Then comes launch, and every 20 seconds, another jet is fired off the bow. 4 catapults, 4 simultaneous channels, a 48,000-pound aircraft going from 0 to 165 miles per hour in 2 seconds flat. That acceleration, that force, is tremendous, and it requires precise calibration based on the weight of the aircraft and the wind speed over the deck. After launch, those aircrafts are on their mission for 60 to 90 minutes. While they're gone, the deck crew is resetting, moving aircraft, rearming jets for the next event, fueling up, checking equipment, running inspections. The moment the first jets come back for recovery, the next event is already being set up for launch. That overlap, launching one group while simultaneously recovering another, is the heartbeat of carrier aviation. And it is not done carelessly. Aircrafts are non-concurrently sequenced whenever possible, meaning the carrier avoids launching and recovering at the exact same moment, because the recovery zone and the launch catapults share the same deck space. The angled flight deck, a design innovation that's been standard for decades, is what makes even partial overlap possible. By positioning the recovery area at an angle from the center line, jets can land on the angled deck while other aircrafts are staged forward at the bow catapults. Without that angled deck, every landing would require the entire forward section to be cleared first, slowing everything down dramatically. The catapult and the wire, 2 miracles of engineering. Let's talk about the 2 most critical mechanical systems on the flight deck, the catapult and the arresting gear. The steam catapult used on Nimitz-class carriers works by releasing a massive burst of steam into a cylinder under the deck. That steam drives a shuttle down a 300-foot track. The jet's nose gear is locked into that shuttle, and when the steam fires, the jet goes with it. 0 to 165 miles per hour in 2 seconds. The energy involved is staggering. Every launch is calculated precisely. How much steam, how long the valve stays open, all based on the weight of the aircraft and wind conditions that day. The arresting wire system is equally impressive. There are 4 wires stretched across the landing area. A pilot comes in low and fast, drops the tailhook on the rear of the aircraft, and aims to catch one of those wires. The ideal catch is the third wire. Experienced pilots and instructors consider the third wire the mark of good approach. When the hook catches a wire, that wire is attached to a hydraulic system below deck. The wire pulls a piston through a cylinder filled with fluid. As the fluid is forced through small holes in a cylinder end, the energy of the aircraft is absorbed and the jets stop. In less than 350 feet, an arresting wire can stop a 54,000-pound aircraft in that distance. And once the wire is released from the hook, the system resets, ready to catch the next aircraft in 45 seconds. Now, remember that thing we said earlier about every landing being treated as possible failure? That's called a bolter. If the hook misses all 4 wires, the pilot must go to full power immediately, because the deck ends and beyond the deck is ocean. The jet roars off an angled deck at full throttle, climbs out, goes around, and tries again. A bolter is not a crash. It is a built-in contingency. Every carrier pilot trains for it, expects it, and handles it as a routine. That mindset, that even the worst case scenario is anticipated and prepared for, is a big part of why carriers can sustain 1,000 flights a week without catastrophe. The brain of operations, CATCC, and the air boss. The flight deck is a physical stage, but the real coordination happens in 2 places you can't see from the outside. The first is called the Carrier Air Traffic Control Center, CATCC, and it operates like a specialized air traffic control room below the flight deck. Inside CATCC, there is a departure controller, a marshal controller, 2 approach controllers, and 2 final approach controllers, all working at the same time. Their job is to manage every aircraft that is not physically on the deck, meaning every jet that has just launched, every jet on mission, and every jet queuing up to return. They use radar and radio to sequence returning aircraft into an orderly recovery pattern called the Marshall Stack, where jets circle at different altitudes and intervals until it's their turn to make the approach. The second place is pre-fly, primary flight control. This is the glass-walled room high up on the island structure on the starboard side of the ship. The air boss sits here. His authority covers every aircraft within 5 nautical miles of the carrier, from the surface up to 2,500 feet. He sees the flight deck below him, and he hears everything happening on the radio channels. Nothing is launched without his signal. Nothing lands without his clearance. Together, CATCC and pre-fly form a complete chain of control, from the moment a pilot starts engines to the moment the tailhook catches the wire. The forward-class upgrades, MALs. Now, the Nimitz-class carriers have been doing all of this with steam catapults since the 1950s. And steam works, and it's rugged, and it's proven. But steam is also maintenance-heavy, energy inefficient, and limited in how quickly it can reset between launches. The Ford-class carriers, America's newest generation, replace steam with something called EMALS, the Electromagnetic Aircraft Launch System. Instead of a steam piston, EMALS uses a linear induction motor, the same basic principle as a roller coaster launch system, but scaled to a carrier aviation. A magnetic field accelerates the launch shuttle instead of a blast of steam. The advantages are significant. EMALS regenerates faster between launches, allowing jets to leave the deck in quicker succession. It can be more precisely calibrated for different aircraft weights, critical as carriers increasingly operate a wider range of aircraft types, and it puts less stress on the airframe with each launch, which extends the service life of every jet it throws into the sky. The Ford class also has a 33% larger flight deck than its Nimitz predecessors and runs with roughly 900 fewer sailors, thanks to the automation that handles tasks that once required human hands. The result is a higher sortie generation rate with a leaner crew. During the Ford's first full deployment, from May of 2023 to January of 2024, the ship completed 8,725 catapult launches using EMALS. That's across 8 months of real-world operations. The systems had early reliability challenges, and engineers continue to refine it. But the data from that deployment shows a system that, when functioning well, is genuinely more capable than anything that came before it. The human factor. Everything we've talked about, the systems, the technology, the catapults, the color jerseys, all of it depends on one thing: more than any other: the people. Between 200 and 300 sailors are actively working on the flight deck during a launch and recovery cycle. Many of them are in their late teens or early 20s. Some are seeing an aircraft carrier flight deck for the first time months before they're running arresting wires under landing jets. They train constantly. They drill procedures until those procedures are second nature. They study what went wrong in past accidents so those accidents don't repeat. The flight deck has been called one of the most dangerous workplaces on Earth, and that reputation is earned. High-speed jets, spinning intakes that can pull a person in, jet blasts that can knock a sailor overboard, steel cables snapping under load, ordnance being moved across a pitching deck in all weather. The risks are real. And yet, through discipline, training, and a culture built on accountability, these men and women sustain 1,000 flights per week. Week after week, deployment after deployment, these are America's best. And what they do on that water, largely out of sight and largely out of the news cycle, is nothing short of extraordinary. Outro. The U.S. Navy's ability to operate a floating airport in the middle of the ocean, launching and recovering jets around the clock, in all weather, at ranges thousands of miles from home, is not something any other military in the world can match at the same scale or the same level of professionalism. It took decades to build. It takes thousands of people to run, and it works because every single person involved takes their role seriously enough to make the whole machine function. 1,000 flights every week without crashing. That's not luck. That's the United States Navy. If you found this video worth your time, hit the like button and make sure you're subscribed, because we cover military topics like this regularly, and you don't want to miss what's coming next.